Welcome to Lesson 10, the one where your nginx finally stops being a black box. Up to now, we've built and hardened the server. Today, we make it observable. 4 loosely coupled pieces left to right. Stub status emits raw counters. nginx-prometheus-exporter translates them. Prometheus scrapes and stores. Grafana visualizes. And OpenTelemetry layers distributed traces on top. 30 minutes of install, and you're seeing rec, sec, P99 latency, and status codes live. Let's map the 4 tiers before we build any of them. Tier 1 is Stub Status, a built-in module since 2009. 7 counters exposed through a single location block, plain text, free. Tier 2, the nginx-prometheus-exporter, is the official Go binary that scrapes that endpoint and republishes it on port 9113 in Prometheus format. Tier 3 is the Prometheus and Grafana pair, 15-second scrapes into a time series DB, plus community dashboard 12708 for instant rec, sec, latency, and status codes. And Tier 4, OpenTelemetry, adds what metrics can't give you. Per request traces showing exactly which backend ate your 340 milliseconds. Now picture the data flowing left to right through those 4 tiers. nginx exposes 7 raw numbers on port 80. The exporter translates them to Prometheus format on 9113. Prometheus scrapes every 15 seconds into its time series database on 9090. Grafana renders the dashboard on 3000. Each boundary is a clean handoff, which means you can swap Prometheus for Victoria metrics or Grafana for something else, and nothing else breaks. That's the power of loose coupling. Let's start at the source. The Stub Status module ships with every nginx build, no recompiling, no plugins, just one directive inside a location block. Bind it to localhost or your VPC range and deny everything else, because this endpoint leaks your request volume to anyone who can reach it. A curl gives you 7 numbers: active connections, the accepts handled requests triplet since startup, and the reading-writing-waiting breakdown of what's in flight right now. That's the entire foundation every downstream tool is built on. Now we wire the rest of the stack together, and it's genuinely just one compose file. The exporter pulls from Stub A status and republishes Prometheus format metrics on 9113. Prometheus scrapes that endpoint every 15 seconds and stores the time series locally. Grafana sits on 3000 and queries Prometheus on demand. 3 containers, 3 ports, 1 job name. For production, you'll add persistent volumes, a retention policy, and alerting rules, but the topology stays identical. Metrics tell you something broke. Traces tell you why. Prometheus flags a P99 spike at 1432, but OpenTelemetry walks you through that exact request and shows back-end search burning 4 seconds waiting on Postgres. nginx Inc. ships nginx-hotel module as a dynamic module, so the install is 3 steps. App the package, load the module, point an exporter at your collector on 4317. Then flip hotel trace on per server or per location, propagate the context downstream, and every request now carries a trace ID end-to-end. Here's all 3 signals living together in one VOST. The log format emits JSON with request ID baked in. That's the magic key, because the same ID rides along in your hotel span, so an access log line and a distributed trace become 2 views of one request. Stub status stays bound to localhost on 8080 for Prometheus to scrape, hotel trace fires on the public 443 server, and the JSON access log writes to disk. 3 lenses, 1 config, 0 overlap. Now step back and ask why we bothered with all 3. Logs answer, what happened to this one request? Perfect for forensics, terrible for trends. Metrics answer, what's the shape of traffic over time? Cheap to aggregate, useless for chasing a single 500. Traces answer, why was this request slow across 5 services? The only signal that follows a request hop by hop. Pick the wrong one and you'll spend hours grepping logs for a capacity question or staring at a P99 graph wondering which user got burned. So here's your cheat sheet. Print it, pin it, tape it to your monitor. 7 directives cover all 3 signals. Stub status, feeding the Prometheus exporter on the metrics side, log format JSON plus request ID on the log side, and the 2 OTel trace directives for tracing. And memorize this number, Grafana dashboard 12708. That's the community nginx dashboard. And it'll save you an afternoon of panel building on every new deploy. Now stop watching and start typing. 3 drills, about an hour total. Exercise 1, 10 minutes to enable stub status and curl it locally, just to prove the endpoint works. Exercise 2 is the big one. 30 minutes to bring up the full Docker Compose stack and watch nginx connections active appear in the Prometheus UI. Exercise 3, 20 minutes to wire Grafana to Prometheus and import dashboard 12708. When you're done, you've built the same observability stack that's running in production at most companies. Once your stack is running, avoid the 5 traps that quietly kill its value. Don't expose stub status publicly. Bind it to 127.0 by 0.1 or allow private IPs only. Otherwise, you're handing competitors your traffic numbers. Dashboards without alert manager rules are decoration. Pick 3 to 5 SLO alerts on error rate, P99, and connection saturation. Sampling traces at 100% will bankrupt your tracing backend. Head sample at 1 to 5%. Or tail sample on errors and slow requests. Never log request bodies, metadata to logs, bodies to sampled traces, PII nowhere, and standardize your log format and request ID header across services, or correlation becomes a join nightmare. And that's lesson 10. 3 signals, metrics, logs, and traces, flowing through 4 tiers. Stub status feeding the exporter on port 9113, Prometheus scraping every 15 seconds, Grafana dashboard 12708 rendering it, and OpenTelemetry threading per request context through the whole stack. Next up, lesson 11. We take this same nginx and deploy it cloud-native as Ingress nginx on Kubernetes. See you there.